All right, grade 11s, what we're going to do now is look at the reduction formulae, which is a method that we're going to use to take large angles bigger than 90 and reduce them to acute angles. In other words, angles that are smaller than 90. It just makes everything a little bit easier when we're simplifying bigger questions. All right, so we're going to start looking at sine 20, sine 160, sine 200, sine 340. You'll see that all of them get the same answer except for sine 200 and sine 340, it ends up being a negative answer. So let's just look at the graph here. From 0 to 90, that's where 20 is, roughly there. Right? Sine is above the x-axis, so sine is positive. Then from 90 to 180, we have 160 about there. Sine is also positive, above the x-axis. But as we go underneath, sine is now a negative graph. So from 0 to 180, it's positive. From 180, here's 200, it's negative. And then as we go up to 360, here's roughly 340. You can see if we dot to here and we dot to there, those are the values where they're positive and negative. So we could have endless values on the sine graph where it's going to be equal to that 340. Sorry, not 340, 0.34. And negative 0.34, and that's what we're going to look at later with the general solution. All right, so for now, the idea is we're just working from 0 to positive 360. So there's 0, okay, and that's where we get our cos diagram from. So from 0 to 360, in our first quadrant, 0 to 90, all sine, cos, and tan graphs will be positive above the x-axis. Then from 90 to 180, only the sine graph is positive. Cos and tan graphs are negative. Tan from 180 to 270 is positive. Cos 270 to 360 is positive. The others will be negative. So we use this cos diagram method in order to reduce bigger angles from 90 to 360 into acute angles of 0 to 90. So let's have a look at some examples. So cos 300. The first thing you've got to ask yourself is, where is 300 on the cos diagram? It sits over here. So it's in cos's quadrant, so your answer is going to be positive. So now you have to ask yourself, 360 minus what will get us 300? And it's 60 degrees. Now that's the acute angle we're looking for. So cos of 300 is the same as positive cos of 60 degrees. And cos of 60 is a half. Now you don't have to put the positive there. You can leave that off, but it's positive because it's in cos's quadrant. And the cos graph would be above the x-axis. Now looking at sine 150. So you ask yourself, where is 150? 150 sits over here between 90 and 180. So you have to say 180 minus what is going to get me 150? And it's going to be minus 30. So, because it's in sine's quadrant, its sine is positive 30 degrees, which is also equal to a half. Now, if you have a look here, based on our co-ratios, cos of 60, sine of 30 is getting us the same answer. That's because 60 and 30 make 90, so they are complementary ratios. Now having a look at tan 200. 200 sits here. So 180 plus what is going to get us to 200. So we are working with 180 plus 20. So we can go back here, and so that is tan's quadrant, so it's positive 20 degrees. Now, because it's not a special angle, we can't go further unless we're allowed to use a calculator, which in these types of questions, you're not allowed to use a calculator. So we just leave it like that. Now, cos 160. 160 sits here in sine's quadrant. So we need to ask ourselves, 180 minus what is going to get us 160? So it's 180 minus 20. Now, because we're in sine's quadrant and we're working with cos is going to be negative. So we're working with negative cos 20 degrees, which we have to leave because we're not allowed to use a calculator. Sine 190, if we go here, 190 sits in tan's quadrant. So it's got to be 180 plus something is going to get us 190. So it's going to be 10. But because we're in tan's quadrant, a sine graph will be negative between 180 and 270. So tan's graph, sorry, not tan there, sine will end up being negative. All right, so negative sine, 10 degrees. We have to leave it like that because it's not a special angle. All right, and the last one here is tan 320. So 320 is going to be in this quadrant. So you have to ask yourself, it's going to be 360 minus 40 degrees. But because we're in cos's quadrant, we are working with a negative tan 40 degrees. Have to leave it like that. It's not a special angle. All right, just two additional questions. If we have a negative angle, you're going to first do your negative angle rules. So tan of a negative angle is negative tan of that angle, which then we're going to look at the tan 150, which takes us to this quadrant over here, sine's quadrant. So we end up with sine's quadrant making tan negative, and it's tan 180 minus 30 degrees. So it ends up being positive tan 30 degrees, and that's the effect of the negative angle and the reduction. And tan of 30 degrees is root 3 over 2, which is a special angle. Then when you have angles that are bigger than 360, you first have to remove 360 because we're not on our cast diagram. So we only go up to 360 on the cast diagram. So we start going around in another revolution, which means that first take off the 360, and then we can see we're in tan's quadrant now. So cos is going to be negative cos 20 degrees, 180 plus 20. An alternative to this tan negative 150, if you forget your negative angle rules, you can also get it onto the cast diagram by adding 360 until it's positive. So it becomes tan 210, which takes it to its own quadrant, and it's going to be 180 plus 30. So we end up with positive tan of 30 degrees, which is root 3 over 3, which is the same answer. So it's a slightly different spin. So you don't have to do it using the negative angle. You can add 360 to it. So if it's negative, you add 360 to get onto the cast diagram. If it's bigger than 360, you can subtract 360 until you, as many times as you need until you get onto the cast diagram.